Okay, class, let's learn sig figs. That's another way to say significant figures. Okay? So it's a method of writing a number which identifies how significant, how accurate the measured value is. The number of significant figures in a result is simply the number of figures that are known with some degree of reliability. So we're going to learn about how to identify how many sig figs are in a number, and then we'll also then learn what's important about them. So first of all, let's learn the rules. Rule number 1. When we're talking about numbers, we're using numbers 0 all the way up to 9. And in fact, the first rule covers 90% of them. Any number that is not a 0 is significant. So is in yellow there, that means any number that is 1, 2, 3, 4, 5, 6, 7, 8, or 9 is significant. So 4, 3, 2, there's 3 numbers that are significant. 1.37, 1.237, 4 sig figs. Follow along, write them down. And 654,321.12345 will be 12 sig figs. So that rule covers 90% of the numbers. Well, the only thing that we left out is zeros. So every other rule down here below all have to do with zeros. And zeros have 3 locations of where they can be. They can be in the middle, they can be to the left, and they can be to the right. So it looks like we need to have 3 rules for zeros. In fact, we end up with 4. So the first rule is about middle. Anything that is a 0 and that is surrounded by non-zeros are significant. So this is a 0 and it's surrounded by a 4 and a 2. So that means that 0 is significant. The 1.007, these are surrounded by 1 and 7. That's surrounded, that's surrounded, that's surrounded. So all those ones that I'm highlighting, all those zeros that I'm highlighting in yellow are significant. So that means there are 4. Again, there are 12 in this one. And this one is 6. Let's see if I can do this. Zooming. Okay. So we're back here. So any zeros that are surrounded are significant. Upcoming, the first rule that is not. Oh, not. There we go. First blunder. As I try to scroll, nothing's happening. So let's just and bring it back up. And there we go. It's Windows products. Shh. So now the second rule here about zeros, which is rule number 3, we're still talking about zeros. Like I said, all the rest of the rules are all about zeros. This is the ones that are in front, the left. And now I'm going to highlight it in purple. These are not significant. So let's just highlight which ones are not significant. Well, there's a 0 in front. Those are zeros in front. These are in front. Notice, I just did it. Let me undo that. Not in front of the decimal. In front of a number. So those, all those are in front. Those are in front. Those are in front. That one is in front. Okay? So all those are not significant. The ones that are still are ones in between. That's what I've covered. The ones in between are. So how many sig figs does each of these numbers have? 0.007. How many sig figs? 1. 0.010101? 5. And 0.9? 1. Okay? So that does cover quite a bit of it. We cover every number from 1 to 9 is. Zeros in the middle are. Zeros to the left are not. There's only one location left, and that's to the right. But there are 2 rules for that, because we now have to split it down and get a little bit more detailed. It depends on what? It depends if there is no decimal point or if there is a decimal point in the number, anywhere in the number. Okay, let's just identify the decimal points with this green. There's none in this one, and every one of these has a decimal point down here. So rule 4 is when there's no decimal point, and it is again a no. They are not significant. So that means highlighting, these are not significant. These are not significant. That is not significant. Anything to the right of a significant number, any 0 to the right of a significant number are not significant if there is no decimal point. So how many sig figs do we have? This will be 1 is the first one, this will be 3, and this will again be 3. So that's an interesting one. Let's try and make up another number here. 10110. How many sig figs does that number have? 4. Okay? Don't ask why or what does that represent, but why? Because of our rule number 4. And number 5, the last one to do with zeros, or when they are to the right. Let's highlight the zeros and let's go to yellow because we are doing the ones that are significant. So that means these are significant. This is important. This is the first big catch me one. Everyone, eyeballs right here. Take a look. 0.0500. I'm highlighting the zeros that are to the right. Not the right of the decimal, but the right of the last sig fig number. Not to the right of the decimal, but to the right of the last sig fig number. So rule 3 says these two are not significant. And rule 5 says those two are. So that's to the right, that's to the right, these two are to the right, that's to the right, and those two are to the right. So 123.0 will have 4 sig figs. 0.00505050 will have 6 sig figs. Write these numbers down, folks. They're on your sheet. Okay? This is the first number that's in scientific notation. And it's important because we deal with a lot of scientific notation. And it's very easy. How many numbers you write down before the times 10, that's how many sig figs there always are. That's the rule. Because there's a decimal when you write scientific notation. So this will be 3. You don't have to worry about the 23. You don't have to worry about the 10. You just look at the 1.00 in this case. 3,450 with the decimal point there, that'll be 4 sig figs. And 40.0 will be 3 sig figs. That deals with all the rules for numbers. The 1, 2, 3, 4, 5, 6, 7, 8, 9 are. The zeros in the middle are. The zeros to the left are not. The zeros to the right when there's no decimal are not. And the zeros to the right when there is a decimal are. What other types of numbers are there? There are numbers that are exact. That's our 6th one. And how do you tell an exact one? Well, an exact one are when you count them. Okay? When you count, you might not be correct on your counting, but when you count, there are 35 chairs in my room. That number of 35 is exact. Another word for exact, for the number of sig figs, is infinite. Infinite number. If they ask for the number, you write down infinite, or you can write down exact. Anything that you count, anything that's a number in a conversion formulas, most of them are exact. 1/2 base times height. Is that 0.5? Only 1 sig fig? No. That 0.5 is actually infinite sig figs. The formula is exactly 1/2 times the base times the height. And centimeters to meters. Those conversions, those metric conversions, those are also exact. So that 100 there and that 1 there are infinite. Now, there are some conversions that are not. The 2.54 centimeters per inch, that's not exact. That's only 3 sig figs. So in my course, how do you know that they're exact? if it has a weird unit. Chairs. Things that are not measured with like a ruler. So kilograms or meters or centimeters, those are all measured. But the number of chocolates in a box, the number of eggs in your recipe, these are counted. When they're counted, you write down exact. So, now that you have the rules, try them out. Try out these 21 questions. And you on YouTube, this would be the perfect time to get those 21 answers. And yes, that's an exact number, 21, because that's counted there. And here are your answers for the interneters. And thank you very much for watching. Remember, smash the subscribe button. I'm just kidding.